Hey, welcome back to Perry University. My last video, we went over how to just do some basic hexadecimal conversions, and this video is just going to be a walkthrough of some practice problems for hexadecimal, kind of get the muscle memory built in, get some good grades on those tests coming up. So on the left side of the screen, there's that table that I had in my last video, where you can see you got all the hex values in the left column, the equivalent decimal values in the middle, and then their binary equivalents on the right column. So we're going to use that for some reference. So let's go ahead and start out with a pretty difficult problem. Let's do 3000 base 10, and let's convert that to hexadecimal. And first, let's do it what I would consider to be the more straightforward way. Let's convert it to binary first, and then we're going to use the binary to convert it to hexadecimal, which is probably what you should do on tests just to kind of simplify things. Even though there's more steps, it keeps it straightforward. The first thing we're going to do is go ahead and write down 3000, and we're going to subtract our largest power of 2, which is less than or equal to 3000, which is, in this case, is going to be 2048. You need to remember that number, it's important. Go ahead and take their difference, and you're going to be left with 952. Take our 952 down here. 512 is going to be our biggest power of 2, less than or equal to 952. 952 minus 512 is going to be 440. Write down 440. 256, our next power of 2, less than or equal to 440. You need to remember 256. That leaves us with 184. Take down our 184. And now our biggest power of 2 is 128. Their difference is 56. We're going to have 56 minus 32, which leaves 24. And 24 minus 16 is going to be 8. And then 8 is equal to a power of 2. Of course, that is 8. Their difference is 0. And that's how we know we're done. All right, just shifted those over to give myself a little bit more room. All right, now let's take what we found and use that to write our binary number. So remember, all those underlined numbers are going to be your powers of 2 that are going to have a 1 as opposed to a 0, 1 being on or present or true, whichever word you want to use there, 0 being it's not present or it's turned off. So in binary, remember the first column is your 0 column. 2 to the 0 is 1. Do we have a 1? We do not, so 1 is off. Next is 2. We don't have a 2, that's off. 4, nope. But we do have an 8. After 8 is 16. After 16 is 32. We have a 32, so it's there. Then 64, nope. 128, yep. 256, yep. 512, yep. 1024, nope. 2048, yes. And there's nothing past that, so we are done. And we'll go ahead and make it formal, put some parentheses around it. Right, base 2, so we know what we're working with. All right, let's make some more room and use that to convert our 3000 into a hexadecimal. Okay, now that we got some more space and we have our binary number written out, we're going to go ahead and separate into 4 bits at a time here, starting right to left. So 1, 2, 3, 4, draw a line. 1, 2, 3, 4, draw a line. 1, 2, 3, 4, excellent. So now it's real simple. All you do is you're going to write the hexadecimal equivalent to each one of these 4-bit binary numbers. So let's start with 1000. That is going to be an 8, and we look at our chart, hexadecimal 8, decimal 8, yep. So 8, there we go. 1011, let's find that over here. 1011 is going to be 11. But of course, we don't want 11 decimal, we want 11 hexadecimal, which is B. And we have 1011 again, so once again, B. And that's it. 0, X, B, B, 8 equals 3000. And you're done. And that's just the simple converting your decimal number to binary, binary to hexadecimal. Now let's try just converting 3,000 straight to hexadecimal. And you're going to see this as a little bit more complication in my opinion. Okay, so just like converting to binary, we need to know our powers of 16. So 16 to the 0 is 1, 16 to the 1 is 16, 16 squared is 256, 16 cubed is 4,096. First thing we do, we're going to write down 3,000. Now we have to have the biggest power of 16 less than or equal to 3,000. In this case, if we look over there on the right, it's going to be 16 squared, and it's 256. However, that's got to be multiplied by some number. That number is going to be the amount of times 256 goes into 3,000. In this case, 256 goes into 3,000 11 point some number of times, but you just truncate those decimals, and this is just going to be an 11. Now that underlined 11 for this position is going to be the number that you need to remember, because that's going to be what we end up using to use our actual hexadecimal value. All right, so now we're going to have 3,000 minus 256 times 11, which is 2,816, and that equals 184. Bring down your 184. We're going to do the same thing, except now the largest power of 16 that goes into 184 is just 16 to the 1, which is 16. Now, how many times does 16 go into 184? It goes into it 11 times and some decimal. Again, get rid of those decimals. We're just going to go down to the nearest whole number. So it's 16 times 11 once again. That 11 is going to be underlined because we're going to need to remember that. Now we have 184 minus 176. And that's going to equal 8. Bring down 8. 8 minus, now the largest power of 16 that can go into 8 is 16 to the 0, which is just 1. And 1 times some number goes into 8, and of course it's 8. So now we have 8 minus 8 equals 0, and that's how we know we're done. So now we need to look at our underlined numbers, which is the 8, the 11, and the 11. And we're going to go right to left. So in the 16 to the 0 spot, we have 8. Pretty straightforward. In the 16 to the power of 1, we have 11. But 11 obviously isn't going to work here. So we look at our chart, and 11 is B. And once again, we have an 11 in the 16 to the power of 2 spot. We know that 11 is B, so we'll go ahead and write B again. And there you have it, 0x BB8. Just remember that 0x leading a hexadecimal number just indicates that's a hexadecimal number. That's it. All right, let's convert another decimal number to hexadecimal. Let's use 91 because why not? So let's convert this to binary first. So we're going to write down our 91. Largest power of 2, less than or equal to 91 is 64. Underline 64. That's going to leave us with 27. Bring down 27. Largest power of 2 inside of 27 is just going to be 16. Remember our 16. That's going to leave us with 11. Bring down our 11. Largest power of 2 less than or equal to 11 is going to be 8. That's going to leave a difference of 3. Next is 2. It's going to be 1, and then 1 minus 2 to the 0 is 1. So now we have 0, and that's how we know we're done. All right, starting right to left for our binary. Do we have a 1? Yes. Do we have a 2? Yes. Do we have a 4? No. Do we have an 8? Yes. Do we have a 16? Yes. A 32? No. A 64? Yes. And we're done. All right, let's split this into 4 bits at a time. 1, 2, 3, 4. Draw a line. 1, 2, 3, and we can draw a leading 0, 4. There we go. 1, 0, 1, 1. Once again, that's going to be B. Keep getting B in my examples. Don't do that intentionally. Then 0, 1, 0, 1. That's going to be the equivalent to 5. So we should end up with 0x 5b for converting 91 to hexadecimal. All right, now let's go from hexadecimal to regular decimal. Let's try it without going through binary first. So let's remember our columns. This is the 0 column, 1 column, and the second column. Remember that's 16 to the 0, 16 to the 1, and 16 squared. Just kind of keep that in mind for the second. All right, so the first thing we want to do is go ahead and write down our 3. And that's going to be times 16, because it's base 16, remember that, to the power of 2. There we go. And we're going to add that to a times 16 to the power of 1 plus b times 16 to the power of 0. Okay, so 3 times 16 squared is the same as 256 plus, all right, now let's pause for a second. A times 16 to the 1, that's going to be a number times just 16. But we obviously can't just multiply 16 times a, so let's reference our chart. Let's find the a column. That's 10. So 10 times 16 to the 1 is just 16, plus, same thing with b. Can't do b times 16 to the 0, but b is 11 times 16 to the 0 is just 1. So now we have 768 plus 160 plus 11, and that's going to equal 939 base 10. And we're done. All right, let's do that same number, 0x3ab, but let's convert to binary first. So b, a, 3. We know b is 11. That in binary is 1, 0, 1, 1, because that's 1, 2, which is going to be 3. We don't have 4, but we do have 8. 8 plus 3 is 11. And 11 is b. I'm going to draw my line. All right, a is the equivalent to 10. Look at the chart. It's going to be 1, 0, 1, 0. There we go. Draw our line to separate. And then 3 should just be a 1 and 2 together, so it should be 0, 0, 1, 1. Look at the chart. Sure enough, it is 0, 0, 1, 1. All right, so now our binary number is 0, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. Now I like to go right to left, and all we're going to do is just do this real quick and dirty. We're just going to sum all the values that are on. So we start out on the right. Do we have a 1? Yes. A 2? Yes. 1 plus 2 plus. Do we have a 4? Nope. Do we have an 8? Yes. That's 4, that's 8. Do we have 16? No. Do we have 32? Yes. 64 is off. 128 is on. 256 is on. And 512 is on. When you sum up 1 plus 2 plus 8 plus 32 plus 128 plus 256 plus 512, you again get 939 base 10. And that's just the second method of doing this. Let's do one last example where we use the powers of 16 to convert F9 in hexadecimal to a decimal number. So the first thing we're going to do, we're going to write F down. That's going to be times 16. It's in the that's 0 column and 1 column. In the 1 column, so that's 16 to the power of 1, base 16 for hexadecimal. Remember that, super important. Plus 9 times base 16 to the 0 column, or power of 0. Simplify this, so let's look at F. F is 1, 1, 1, 1, which is 15, times 16 to the 1, which is obviously just 16, plus 9 times 16 to the 0, or 9 times 1. 15 times 16 is going to be 240, plus 9 times 1 is 9. Add those together, what do you get? 249, and that's going to be a decimal number. You're done. All right, I hope those examples were helpful. Hope you got some muscle memory in there. Hope you maybe learned a little something. I hope this helps out on any tests you might take, or if you want to learn this just for fun, I think that's great. Feel free to no, I'm not going to say all that garbage. Feel free to leave any comments with any questions. I will answer them, I promise. Don't subscribe if you don't want to. Only do that if you feel like I'm worthy of that. All right, thank you so much for your time. Hope you have a great day.